We are working on query matching methods. In the first part of the section, we considered the vector space model directly applied for the term document metric. In the second section, we'll study the so-called latent semantic indexing. It is based on the assumption that there is some underlying latent semantic structure in the data, and that this semantic structure can be enhanced by projecting the data onto a low-dimensional space, such as a space of principal components. We can do this by using the singular value decomposition. Let's see the algorithm, latent semantic indexing. We start with the singular value decomposition of the term document metric. A is U sigma V transpose. Now we approximate it onto a k-dimensional space. So AK is k-dimensional approximation, and written in this way. We are choosing only k components. Now we can rewrite this product in this way, UK and DK. Now the columns of UK form an orthogonal basis in the document space, while each column of DK holds the coordinates of document J in terms of the orthogonal basis. Now, to find the cosine, we need this product. That is basically dot product along with the query vector and the approximation of a k-dimensional approximation of the term document metric. So we have to compute this one. Now in detail, we can reach this one, right? It's AK is the same as now here, so that we can rewrite this in this way. This is a vector, and this is a metric. Okay. So for query matching, we have to get that one, so that, and if we start with a J's column over there, then we can write in this way. This is J's column. So that for along with this vector and J's column and the product, that is exactly this one, and then divided by the length of each one. So it becomes the cosine. Okay. Now in this way, we can find the cosine angle, and now in the k-dimensional space. Okay, let's see how it is working. Query matching is carried out for the query Q9 in the Medline collection. And now using only 100 the basis vectors. And as you can see in this figure, the recall pressure curve is moved toward this corner. Earlier we considered this the curve, and once curve is moving toward this upper right corner, then we may consider the algorithm is better. So for this 100-dimensional approximation, now this is better. Okay, that's one result along with the Medline collection data set. Okay, we'll go to now the simple problem example, two example. And we used this one earlier and consider the term document metric and given here, and this document and this query vector corresponding to this query ranking of web pages. So we have to compute the angle cosine and by approximating this term document metric into two-dimensional space. So that is what we are trying to do. And in this paper, it is presented. Okay, obviously, from this document and query, we can see that document 1 is not really relevant. So obviously, no. I'm sorry. Document 5 is really irrelevant, and 1 to 4 are relevant with the query. However, if we try to get the cosine and for the query along with the original metric, this term document metric, then we can get this result. But number 1 to 4 must be relevant, but it has 0, so that it's not really a good approach to get the relevant documents. Now, we are using the singular value decomposition, and we try to use two-dimensional subspace through the projection onto the two-dimensional principal component space. Then, and along with this approximation, transformation, the cosines are obtained in this way. Now, compared with this original cosine values, you can see here this one is now changed into relevant. So document 1 now can be considered as a relevant document, and also DF3, the values are enhanced, and this irrelevant document has lower cosine value. So this two-dimensional approximation of the term document metric works better. And however, this is not a cure-all. If you, for example, and if you choose three-dimensional or four-dimensional, then what happens? And when you choose two-dimensional space, it works better. But for general data set, how can you find this transformation and the lower dimensional space? In general, it's not easy. And also, if you don't have any ground truth information, then you don't know which one is better. So even though for this example, really when low dimension is 2, then way better. However, you have to consider this approach as an opportunity or possibility. However, always you should consider this one as a warning also. Okay? Okay, that's the end of section. Thank you.